That's my best approximation of a shell. Hey team, I'm Maddie. Welcome to Science Side Up, and today we're going to talk about paleoclimate. Paleoclimate is the field of science that studies Earth's climate in the past. And what I want you guys to start thinking about are kind of two main things. One, what are questions we can actually ask about Earth's past climate? And two, how do we go about figuring out the answers to those questions? So an example of a bad question would be something like, did it rain on July 12th, 5000 BC? That's not a question we can really get a good answer to, but a good question might be, was the year 5000 BC warmer or colder than it is today on average? Did we get more or less rain or precipitation globally then than we do now? How much carbon, specifically carbon dioxide or methane, was there in the atmosphere? Even were Earth's oceans saltier then than they are now? So those are some questions that we can realistically ask of the past climate. And now let's think about how we ask those questions or how we get answers to those questions. My favorite question in science is, how do you know that? So how do we know what Earth's temperature was like 5,000 or 5 million or 500 million years ago? And that's what we're going to talk about today. And today we're specifically going to talk about temperature, because I think it's one of the kind of bigger questions, one of the more common things that's talked about. What we need to look for are proxies. That is, things that we can find today that existed in the time period we're interested in, and specifically that were affected by the temperature in some way, if we're looking for a temperature proxy. There are a lot of different types of proxies that tell us about different climate parameters at different periods in Earth's past. So we can use anything from tree rings to pollen to like fossilized plants and corals and even just sediment deposits. All of these things can tell us about the past climate. If you're interested in lots of different types of proxies, I put a link to a really great resource from the US Geological Survey. It's down in the description. It's a pretty easy read explanation of different types of climate proxies, which it's a great read. But today we're going to talk about a very specific type of climate proxy. We're going to talk about mollusks. Mollusks are great. They have been around on planet Earth for about 550 million years. They have shells, so those shells are hard, which makes it easier for that shell to survive 500 million years for you and I to go dig up, as compared to say like soft tissue, which is gonna be just completely destroyed quickly. And very specifically, these mollusk shells are made of calcium carbonate. So calcium carbonate is one calcium atom, one carbon atom, and 3 oxygen atoms. And we're actually pretty interested in that oxygen atom. Let's say you and I, this is me and this is you, and we have pickaxes for digging. That's how you find mollusk shells, right? So we both dig down in the ground and we find mollusk shells, and mine is 4 million years old from the Pliocene era, and yours is like 50 million years old from the Eocene era. And then we take our mollusk shells to a lab and we have them measure the ratio of oxygen isotopes. So oxygen 16 and oxygen 18 are specifically what we're interested in. And we're interested in measuring this ratio. So 8 oxygen, 18, there are 8 protons in oxygen, and oxygen 18 has 10 neutrons. So we've got 2 extra neutrons here, then our oxygen 16, 8 oxygen 16, 8 protons, 16 minus 8 equals 8 neutrons in the nucleus. Both oxygen 16 and oxygen 18 are naturally occurring isotopes that are stable. So that means they're not going to radioactively decay. So basically, once we make our calcium carbonate and we make our shell, that amount of oxygen 16 and oxygen 18, it's just gonna stay put. So we take our shells to the lab, we measure this ratio very carefully, and we're gonna find that your sample, your mollusk shell, has...
Stop it, Past Maddie. Past Maddie is about to misspeak and flip the relationship between oxygen isotopes and temperature on the board. And editing Maddie caught that, so good job editing, Maddie. But I already filmed the whole thing. So the warmer it is, the less oxygen 18 is incorporated. The warmer it is, the less oxygen 18, and the colder it is, the more oxygen 18 to oxygen 16 ratios there are. Forgive the interruption. Back to Past Maddie.
So that tells us that it was warmer 50 million years ago than it was 4 million years ago. Now, let's do this with lots of different mollusks from lots of different time periods and other things that also incorporate oxygen into them. Calcium carbonate's a great example to use, but we can use other proxies to get at this. Scientists have been able to construct this timeline of Earth's temperature past. And you can pretty clearly see on this graph, there's that Eocene versus Pliocene. Eocene was definitely warmer, and it was done basically by the type of experiment we just talked about and described. So I think that's so cool, and I think it's so much fun to really wrestle with, like, how do we figure things out about Earth's past, especially the climate? You know, it's one thing to have like, oh, okay, I have this rock, I can figure out how old this rock is because I can like hold it in my hand, but you can't exactly hold the atmosphere in your hand. So you've got to figure out that second step of the atmosphere is going to affect this thing, which then gets incorporated into this other thing, and this other thing is what we can measure. So yeah, okay, sorry, I'm rambling. I love paleoclimate. I think it's so cool. Okay, team, that's all I've got for you today. I hope you and those you care about are well. Join us next week. We're gonna talk even more about paleoclimate. But until then, please like, subscribe, be kind, and I'll see you all next time. Bye, team!